Alright, these are the notes for 2.13. So you'll need to follow through in your notes. The first half, or the first part, is talking about the properties that we actually talked about last class. A reminder of properties that when you were adding, if I have x to the second times x to the third, it's going to give you x to the fifth. You're adding your exponents. If it was x to the second quantity to the third, that is x to the sixth. You're multiplying your exponents. And if it was x to the negative 3, that is 1 over x cubed. So again, properties of exponents then lead to properties of logs. Because when your logs have two things that are being multiplied inside the log, you can separate it into two separate logs that are being added. Dividing inside the log means you can subtract two separate logs. And the power means it's going to go in front. Alright. So we're going to talk about solving. Today is all about solving and manipulation. So the first thing we're going to talk about solving is solving with one logarithm or exponent. You are going to isolate that exponential term or that logarithmic term, meaning get it by itself on one side. And then you're going to change forms and then solve for the variable as necessary. Please make sure you simplify around. If it says leave it in exact form, that means you can leave it in the form log of 7. That is an exact form. So, convert to the equation to the alternative form. Here we go. Here's our first one. A says 4 to the x minus 2 equals 7. I need to isolate the 4 to the x. So I'm going to add 2 to both sides. That makes this 4 to the x equals 9. Get the x by itself by changing forms. So I'm going to convert. It becomes log base 4 of 9 equals x. I've solved for x. This is an exact number. I'm going to leave it just like that. That's the exact form. Now, if I wanted a decimal approximation, I would stick this in my calculator. Letter B says 2 to the x plus 3 plus 5 equals 26. The first thing I have to do is to isolate the exponential portion. So I need to move the 5. So 2 to the x plus 3 equals 21. And now I'm going to take it out of exponential, put into log. So it becomes log base 2 of 21 equals x plus 3. But I actually haven't solved for the variable yet, so we need to move this 3 to the other side. Now, this is going to be log base 2 of 21 minus 3 equals x. Please note that the 21, you cannot subtract 3 from it, because this is log base 2 of 21. All of this goes together. The log base 2 of 21 is a separate number, and then you're subtracting 3 from it. And that, ladies and gentlemen, is my final answer. For C, I'm going to do the same thing. Again, I'm going to get the exponential piece by itself, so I'm going to subtract 3. That gives you negative 10 equals negative 4 e to the x. Please note that that is a negative 4, not a positive 4. Again, I haven't gotten the exponential term by itself, so I'm going to divide by 4. So 10 over 4, which, by the way, is 5 over 2, is equal to e to the x. I've got to take this out of exponential form and put it into log form. So it becomes the natural log, because that's log base e, of 5 halves equals x. And that, ladies and gentlemen, is my final answer. So again, these are all could be written as decimals, but it said leave in exact form. These are the exact forms that we're looking for. Again, we have solving these, but I'm going to leave these in exact form as well. Now these are going from logs to exponential, but I'm not going to get in there yet. I am going to first get the log term by itself. So the first thing for number A, to get the log term by itself, I'm going to move the 4. So it becomes 2 log base 3 of x plus 3 equals 6. I'm going to divide by 2. I'm going to have log base 3 of x plus 3 equals 3. And And now I'm going to take it out of log form and put it in an exponential form. So it becomes the base is 3 to the power of 3, there's lots of 3's, equals x plus 3. I'm going to go here because I lost space. 3 to the third I can do. 3 to the third is 27 equals x plus 3. So x equals 24. When you start with logs, you always have to verify that your final answer is okay. If you start with exponentials, I don't care, because I can take the exponent, I can have any number in an exponent without an issue. What I can't have is inside a log, I can't have a negative final answer. So when I put back in 24, I just have to make sure that it's not going to be a negative number. 24 plus 3 is not a negative number, so I'm good to go. If you do get a negative number, that means that it is not a valid answer. Alright, so letter B. I'll put C on the different page, by the way. Letter B. 2 plus log base 5 of 2x minus 1 equals 4. And actually, I'm just going to stick this on a different paper, too. 2 plus log base 5 of 2x minus 1 equals 4. Make sure I wrote that correctly. So again, I need to isolate the log term. So I'm moving the 2. And notice that it's not isolating the log term in terms of the 2x minus 1. I'm not isolating x. I'm isolating the log term. So the log term itself, the log is by itself on one side. And it is right now. So I'm going to take it out of log form and put it in exponential. So 5 to the power of 2, we'll get around the equal sign, equals 2x minus 1. And now I'm going to solve. 5 to the power of 2 is 25, equals 2x minus 1. So, again, I'm solving. So 26 equals 2x. Solving once more. So x equals 13. And again, because it's a log, I'm going to just verify it. I'm going to go up here to the top. And I'm going to say when I put in 13 in here, 2 times 13 minus 1 does give me a positive number, I'm good to go. If it doesn't give you a positive number, then there is no solution. Alright, letter C. Please letter C here. Again, I'm going to isolate the log term. This time it's a natural log term, doesn't really matter. I just need to isolate it, so I'm going to multiply by 5. So I have the natural log of 2 minus x equals 5, because 1 times 5 is 5. And now I'm going to take it out of exponential, out of log and put it in exponential. So it becomes e to the 5th equals 2 minus x. E to the 5th is not a number that I know, so I'm going to leave it as e to the 5th. I still need to solve for x, so I'm going to subtract 2. E to the 5th minus 2 equals negative x. Still solve for x. Divide by negative 1. This makes this negative e to the 5th plus 2 equals x. And I'm going to go up here and I'm going to verify that I'm okay. So I would have the natural log of 2 minus the quantity, negative e to the 5th plus 2. So that would be the natural log of 2 plus e to the 5th minus 2. And e to the 5th is a positive number, so I'm good to go. So again, you always have to verify, and again, please make sure that you're leaving the exact form. So this is an exact form number. Negative e to the 5th plus 2, or 2 minus e to the 5th, are both valid. Do not give us the decimal approximation when it says leave your answer in exact form. Leaving answer in exact form is equal, do not give me a decimal. When you're working with multiple equations, we got to use our properties of logs to simplify things. Okay? So, it all depends on how I can get it down. If I get it to one of the forms that says log base 2 of x equals b, then I can solve it just like I've been doing. If I can get it to where it says log base a of x equals log base a of y, where the log, I've got 2 log bases and they're on the same side, or they're on opposite sides of the excuse me. And they're exactly the same bases, and it's just log equaling log, and that gets at the insides equal to each other. Alright, here we go. Here's the first one. The first one says A, says log of 3 plus the log of x plus 4 equals the log of x minus 2. Well, the first thing I'm going to do is I'm going to deal with the left-hand side. The left-hand side has addition, two logs that are adding. They have the same base. If I have two logs that are adding, the property says that I can write this piece as a log of 3 times x plus 4. Didn't do anything to the right-hand side. That means on the left-hand side, I have the log of 3x plus 12. Didn't do anything to the right-hand side. Oh, but look, I have a log equaling a log. And if I have a log equaling a log, I can set them equal to each other. I'm going to drop the logs. So 3x plus 12 equals 5x minus 2. Now it's just a simple solving. I'm going to subtract 3x. I'm going to go over here because I lost room. 12 equals 2x minus 2. 14 equals 2x. X equals 7. So again, I'm going to make sure when I plug it in, I'm going to check all the pieces in the original problem. 3 is an issue. 3 plus 4, or 7 plus 4 is bigger than 1, or bigger than 0. And 5 times 7 minus 2 is bigger than 0. So I'm good. And that one's a good one. All right, letter B. I'm going to put it on the paper, because I just run on the face. X plus 1, 3 is minus 5 is 7. Natural log of x plus 1 minus the natural log of 3x plus 5 equals the natural log of something. She just needs to make sure she's right. X plus 1, 3x minus 5, and 7. Okay. Again, I'm going to deal with the left-hand side. The left-hand side has a minus sign. Minus sign in logs means subtraction, so it becomes the log, natural log of x plus 1 over 3x minus 5 equals the natural log of 7. Didn't do anything to the right-hand side. But now I have a natural log equaling a natural log. When you do that, and again, it's just literally log equaling log, here and here, I can set the pieces that are inside equal to each other. So, x plus 1 over 3x minus 5 has to equal 7. I'm solving this now. It makes it a lot easier for me to solve. I've gotten rid of the logs. If this is true, I'm going to multiply by the denominator on both sides. So x plus 1 equals 7 times 3x minus 5. One point, these canceled out. So x plus 1 equals 21x minus 35. Now I'm just straight solving. So 1 equals 20x minus 35. So 36 equals 20x. X equals 36 over 20, or if I divide by 2, or divide by 4, 9 over 5. So x equals 9 over 5. What I'm going to do is I'm going to go back up to the beginning, and I'm going to make sure 9 over 5 is fine. That's what I care about. Doesn't make anything go negative. 9 over 5 plus 1, that's greater than 0, so that's good. 3 times 9 over 5 minus 5. That's the question of the day. So that is going to be 27 over 5 minus 5. 27 over 5. The question is that bigger or smaller than 5? Is that bigger or smaller than 0? Right? 27 over 5 is like 25 over 5. That's 5 2/5. So that's greater than 0. So we're good. You have to check your answers because you will have ones that will not work. Alright? Let's go down to C. Again, I have two things that are adding, so I'm going to add these two together. They all have logs. That's a good thing. We're going to add these two together. This becomes log base 3 of x plus 2 times x minus 3 equals log base 3 of 14. Because they both have the same log base, I can get rid of the log base. So I'm going to have the quantity x plus 2 times the quantity x minus 3 equals 14. You have to FOIL, ladies and gentlemen. You're foiling x squared minus 3x plus 2x minus 6 equals 14. Or x squared minus x minus 6 equals 14. Has to equal 0 for me to be able to do anything with it. So I'm going to move things around so that I can get it to equal 0. So x squared minus x minus 20 equals 0. I can factor that. Factors of negative 20 that add to be negative 1 are negative 5 and a positive 4 equals 0. So this time I get two solutions. I get 5 and negative 4. So the question is, are both of them valid? Again, go back to the original problem. Here's my original problem. If I plug in 5, 5 plus 2 is good, 5 minus 3 is good. I have to plug in negative 4. Negative 4 plus 2 is not good. Negative 4 plus 2 does not equal negative positive number. Log base 3 of negative 4 plus 2 is the log base 3 of negative 2, which you cannot do. So this whole thing is out. Because you can't take the log base, you can't take the log of a negative number, which means that negative 4 is not a valid number. So while you're showing it as a solution, you're going to cross it out. We still want to know that you recognize that it was an option. It just didn't work. For letter D, natural log of x minus natural log of 3 equals 2. Again, the left-hand side was nice, because the left-hand side is subtraction, so of log, so I can make a division. The right-hand side is not a log. Because the right-hand side is not a log, you cannot just drop the log. You have to change forms. So we're going to change forms from log form to exponential form. So this becomes base e. So e to the second equals x over 3. I need to solve for x. So I'm going to multiply by 3. So 3e squared equals x. That, ladies and gentlemen, is my final answer. Solve for x. The question is it valid? So 3e squared is a positive number, and when I stick that in natural log of x, I'm good to go. It's a positive number. There's my final answer. We're good on that one. All right. I got a couple more. So if you have not stopped and tried these on your own, you should do that. You should stop this video, try these on your own, and then come back and check your answers if you have not started to do that already. You should try that. All right, example 4. We're again doing the same thing that we have been doing. We are going to solve. So subtraction means, oh, but first, notice I got to get rid of this 3. Because you can't do subtraction yet, that's a power. So log base 4 of x minus log base 4 of 2 cubed equals log base 4 of x plus 7. Got to do that power first. Now I can do subtraction on the left-hand side, which means division. So log base 4 of x over 8, 2 cubed is 8, equals log base 4 of x plus 7. And now I can write these as they're both logs, so I can pull off the base 4s, and I can make it x over 8 equals x plus 7. And I'm going to solve this by multiplying both sides by 8. And I'm just going to come up here. X equals 8 times x plus 7, or x equals 8x plus 56. Negative 7x equals 56. Divided by number 7. x equals -8. So now I have to go back over here, and I have to check my answer in A. When I plug in -8 to the very first one, there's an issue. So that means that there's no solution. I'll do the next one. The next video will be after the fire alarm.